Next, sulfur and its compounds. Sulfur was discovered by the ancient Chinese in the prehistoric period, but was recognized as an element in the second half of the 18th century. It was used as a fumigant in ancient Greece, and it's what is referred to in the Bible as brimstone. It is a yellow non-metallic solid occurring freely in the United States, Italy, and Japan. Sulfur compounds also occur naturally in petroleum, coal, and natural gas. Sulfur also occurs as hydrogen sulfide and sulfur dioxide in hot springs and in volcanic gases. In living things, sulfur occurs as a compound of protein. With atomic number 16 and period 3 in the table, sulfur has an electron configuration of 286 and a mass number of 32. Most common valence is 2, but rarely a 6 when it combines with electronegative elements, for example, oxygen and fluorine. Extra fresh sulfur bed beneath layers of clay, sand, and limestone, which makes open mining impossible due to the risk of collapse. The fresh process is based on the fact that sulfur has a comparatively low melting point. The fresh pump, consisting of 3 concentric pipes, is sunk deep into the sulfur bed. Superheated water at about 170 degrees Celsius under pressure is pumped into the outermost pipe. The water enters the sulfur bed and melts the sulfur pipe. Compressed air under a pressure of 20 to 25 atmospheres is pumped to the innermost pipe. This forces the mixture of the water and molten sulfur to gush out through the middle pipe. This mixture of water and molten sulfur is collected, and on cooling, about 99% pure sulfur gets separated. Allotrope sulfur. Solid sulfur exists in 2 different crystalline forms. These are called rhombic sulfur and monoclinic sulfur. Forms are made up of pure sulfur. They differ in the shape and of their crystals. Rhombic sulfur, alpha sulfur, consists of octahedral-shaped crystals. It is only stable at temperatures below Celsius. Monoclinic sulfur, also called beta sulfur, consists of needle-shaped crystals. It is only stable at temperatures above 96 Celsius. Thus, below 96 degrees Celsius, crystalline sulfur exists in the rhombic form, and above 96 degrees in the monoclinic form. 96 is when a solid exists in several different forms in the same, it is said to show different forms are called allotropes. The allotropes have the same chemical properties, different physical properties. Physical properties of sulfur. Sulfur is a solid which is insoluble in organic solvents like carbon disulfide and methyl benzene. At ordinary temperature, sulfur exists as a solid covalent substance. Each sulfur molecule comprises of a ring of 8 sulfur atoms. The atoms are linked by strong covalent bonds, forming an S8 molecule. Individual molecules are linked to one another by weak intermolecular forces, such as van der Waals forces. The molecules act regularly, forming crystals, and are present in both rhombic and monoclinic crystals. When sulfur is heated, it melts at 113 degrees Celsius to a clear pale yellow liquid that flows easily. At this point, molecular forces are broken, separating the individual molecules, resulting in liquid sulfur. On further heating, the liquid darkens, very viscous and hardly flows. This is because as heating continues, some of the covalent bonds break, leading to the formation of long chains of atoms. The chains get entangled, causing the liquid to become viscous and dark. In fact, at some point the test tube can be inverted without the sulfur pouring out. As heating continues, the liquid becomes black and flows easily once again. This is because more covalent bonds break, resulting into smaller molecules which are less entangled. This makes the liquid less viscous. At a temperature of 404 degrees Celsius, the liquid will boil, forming the molecule. 1,000 molecules will exist as temperature is increased further, single atoms of sulfur will form. Anyway, sulfur is suddenly cooled, pouring into cold water. See what happens. The product is elastic and is called plastic. If plastic sulfur was left for several days at room temperature, it will harden into rhombic sulfur. Good. Now we look at the chemical properties of sulfur. Reaction with air. Sulfur melts and catches fire, burning with a blue flame. It burns in pure oxygen with a brilliant blue flame. In either case, sulfur combines with oxygen to form sulfur dioxide, which has a choking smell. Traces of sulfur 6 oxide are also formed. The sulfur dioxide dissolves in water to form sulfurous acid. Reaction with iron. When a mixture of iron and sulfur is heated to glow, the glow continues and increases in intensity even after the heating is stopped. This shows that the reaction is exothermic. Black 2 sulfide is formed. Other metals like zinc and copper also react, forming metals. Sulfur does. However, concentrated sulfuric acid oxidizes sulfur to sulfur 4 oxide. Again, concentrated nitric acid oxidizes sulfur to sulfuric acid and is itself reduced to nitrogen 4 oxide. Sulfur is used in the manufacture of sulfuric acid, which has a large variety of industrial uses. Vulcanization of rubber, that is hardening of rubber of substance used in metal, manufacture of gunpowder, explosive, matches and fireworks, manufacture of sulfur drugs, insecticides and fungicides, manufacture of calcium hydrogen sulfide for bleaching wood pulp, manufacture of sulfate, which is photography, manufacture of artificial hair dyes. Sulfur 4 oxide. Sulfur 4 oxide is commonly called sulfur dioxide and is a gas at room temperature. It is formed when sulfur burns in air. The gas is released in the atmosphere when sulfur-containing substances such as coal and oil are burned. For this reason, the air of industrial cities contains amounts of the gas. In the laboratory, sulfur 4 oxide is prepared by reacting copper tannings with sulfuric acid. The arrangement is shown here. Copper tannings are taken into the bottom. Concentrated sulfuric acid is poured into the thistle funnel until it covers the copper tanning. The flask is heated. Reaction takes place and sulfur dioxide is dissolved. Sulfur 4 oxide, being heavier than air, is collected in a gas jar by displacement of air. The gas will be passed through concentrated sulfuric acid to remove any moisture if required dry. Sulfur 4 oxide can also be prepared using sodium sulfide and hydrochloric acid. The apparatus setup is similar. Sulfur 4 oxide is a poisonous and colorless gas with a pungent choking smell. It is 1.5 times denser than air. It is very soluble in water. In fact, 1 volume of water dissolves 700 volumes of sulfur 4 oxide. It condenses into a colorless liquid at -10 degrees Celsius. Chemical properties of sulfur 4 oxide. pH. When a wet blue litmus paper is inserted in a gas jar of sulfur dioxide, it turns red. Acidic. And this happens sulfur dioxide combines with water to form sulfurous acid. Bleaching action of sulfur 4 oxide. Sulfur 4 oxide acts as a bleaching agent and bleaches flower coloring matter in the presence of moisture. You can observe here how a moist flower loses the color. The bleaching property of sulfur dioxide is reduction. Coloring sulfur gets to a colorless compound. Standing in the reduced is realized and the original bleaching of dioxide of a temporary nature. The material to be bleached must be wet. This is because water is required to form the sulfite ions, which are responsible for the bleaching action. The gases are then passed into an absorption tower, which is packed with concentrated sulfuric acid flows. Here, sulfur is absorbed in the concentrated sulfuric acid. The result is a highly viscous liquid called disulfuric acid. Sulfur is absorbed directly because the reaction is exothermic. This causes which are all from the previous stage is mixed with calculated quantity of water to concentrated sulfuric acid. This contains sulfuric acid and doesn't work. Pure sulfuric acid is a colorless, odorless liquid, only called petrol. It has a density of 4 grams and is at 338 degrees Celsius. It dissolves in water with evolution of a large amount of heat and has no effect on litmus paper. Note that concentrated sulfuric acid is highly corrosive and should be handled with care. It will cause serious burns if it gets into contact with the skin. When diluting sulfuric acid and any other acid, always pour the acid into the water and never water into the acid and stir continuously. If water is poured into the acid, the heat evolved causes water to boil acid. Chemical properties of concentrated sulfuric acid are different from those of diet acid. Chemical properties of concentrated sulfur acid. Dehydration properties. High affinity. When you add blue hydrated copper to sulfate, draw the water crystallization of the salt. The white anhydrous copper to salt. Concentrated sulfuric acid is added to sugar. A foam and black mass of a substance is formed. The black substance is covered. It appears because of trapped steam. Oxidizing properties. Concentrated acid is a oxidizing agent. It oxidizes metals and non-metals. Metals are converted into their space salts. Metals are converted to oxide. Sulfur to sulfur 4 oxide water. For example, copper turning forming a solution of two sulfates. Metallic copper oxidizes to acid. Electrons are by acid gets reduced to sulfur 4 oxide and water. Copper is the reducing agent in this reaction, and concentrated sulfuric acid is the oxidizing agent. Zinc reacts in a similar way to copper. In this case, however, sulfate and sulfur 4 oxide are formed. Hot concentrated sulfuric acid oxidizes almost all metals, with the exception of those that are very reactive series, such as gold and platinum. That reaction, sulfuric acid produces hydrochloric acid. Acids are more volatile than sulfuric acid. A mixture of a chloride is heated with sulfuric acid, hydrochloric acid vapor with nitric acid vapor distills out. Physical properties of dilute sulfuric acid. Dilute sulfuric acid is a colorless and odorless liquid and turns a blue litmus paper red. Dilute sulfuric acid dissociates into two separate into a hydrogen ion and a hydrogen sulfate. Hydrogen sulfate ion is further into hydrogen ion sulfate ion. In very dilute solution, the acid is completely dissociated, but it has a high concentration of hydrogen and it is the hydrogen ions that give an acid acidic property. Note that sulfuric acid is compound dissociated into ions. For this reason, a strong acid. For example, it does not turn a blue litmus paper red. It does not conduct electricity. Reaction when added to dilute sulfuric acid, indicating a reaction that liberates a gas. The observation shows that dilute sulfuric acid reacts with fire in the reactivity system, forming gas. With copper turning, no reaction will take place, and this